Hey guys, so today we're going to be solving this problem, which is the integration of absolute value sine t times cos of nt dt from 0 to 2 pi, where n is a natural number. So this problem is a bit tricky, but I believe you guys can solve it. So pause the video and give this problem a go. Alright, so hopefully you gave this problem a go. It was a really tricky problem, but I'm here to walk through the solution with you guys. So, how do we first approach this problem? Since I know there's so many ways to solve integrals, there's u substitution, integration by parts, and a bunch of other ways you could solve integration, and having this absolute value over here doesn't really make things better for us. So what we have to do first we have to solve this absolute value. So how do we do that? Well, we can split it into two parts. We can say that the absolute value of sine of t is, it's going to be just sine of t in the range if 0 is less than equal to t is less than equal to pi. And you can see that on the graph to your right. So just follow along with that graph and to find the absolute value of sine of t. Now, in between pi and 2 pi, this will be negative sine of t because it's going to be under the x-axis, but if we take the absolute value, it's going to go above the x-axis, which is why we add a minus. But that's only for this range right there. So now we have solved our absolute value. Now what we have to do, we have to actually make this integrand. We have to incorporate this absolute value into this integrand. So let's just do that. So let's take this integrand. What do I mean by that? Well, we could say that 0 to pi, we know that that is just sine t, so sine t. And then let's leave the cos nt as it is, and then dt. However, we also have this part, so we can say plus pi to 2 pi because of this range right here. And now this is minus sine t. Once again, we keep the cos nt as itself. And there we go. And now what we do, let's just simplify this. Let's simplify this. So actually, we don't really have to simplify it. Let's just write it as it is. So integration 0 to pi, sine of t, cos of nt dt. And then since this minus 1 is a constant, we can simply take that out. So you get minus pi to 2 pi, sine of t, cos of nt dt. And before you automatically cancel these out, since it does look that they're exactly the same, I mean, why not? We have the sine t here, cos nt here, cos nt here, but it cannot be canceled out because the lower bound values and the upper bound values are completely different, so don't cancel those out just yet. So instead, let's solve this integrand, and let's do that right here. So in order to simplify this, we have to apply the product to some formula for sine and cos. So that formula is essentially that if you have maybe sine alpha cos beta, that is equal to 1/2 sine of alpha plus beta plus sine of alpha minus beta. So we're going to use this to solve these two integrands. So let's do that right here. So we can do integration of 0 to pi, 1/2 sine, we have to add this t and nt, so that's basically t plus nt. Oh, and then we also have to add the sine alpha minus beta, which is t minus nt dt, and that's just this part. So now we have to do this for this part as well. So that's basically, sorry, you guys can see it that well. That's minus pi 2 pi to 2 pi 1/2 sine t plus nt plus sine t minus nt dt. So it's going to look something like that. Now let's just further solve this. So let's take this t out. So then, and let's also take that 1/2 out since it's a constant. So let's start by taking the 1/2 out. You get 1/2 1/2 integration 0 to pi sine of 1 plus nt. I just simply took the t out. Let's do the same thing over here. So you get plus sine 1 minus nt dt. Then let's do the same thing for this integrand. We get minus 1/2 integration pi to 2 pi sine of 1 plus n t plus sine of 1 minus n t dt. Alright, so this is going to be our main integrand that we will refer back to, so let's just mark it with a 1. Then what we have to do, let's take two scenarios. The first scenario will be when n is equal to 1, and the other scenario will be when n is greater than or equal to 2. This is because when we solve for n, we get a different answer only when n is equal to 1, which is why we're splitting into two parts. So first off, let's just solve this n is equal to 1. Pretty straightforward. We simply just replace n for 1 in our equation 1. So we get 1/2 integration of 0 to pi sine of 2t plus sine of 0 dt, and then minus 1/2 integration pi to 2 pi sine of 2t plus sine of 0, and then dt. Sorry if it's messy, guys. Let me just move this. Now let's further simplify this. We get 1/2 0 pi sine of 2t dt. This is because sine of 0 is simply just 0. And then 1/2 pi 2 pi sine of 2t dt. Once again, sine of 0, simply just 0. And now what we can do, we can start integrating this. So we get 1/2 integration minus 1/2 cos of 2t 0 to pi and minus 1/2 times minus 1/2 cos 2t pi to 2 pi. And if you don't know how to do this, I suggest you go back and maybe watch some of my previous videos on how we solve these, because it will really help, since in this problem you must know how to integrate and differentiate trigonometric functions, mainly sine and cos. So now that we have that, let's go ahead and solve it. So solving it is going to take a while, so I already solved it for you. I'm sure you all know how to just replace pi in for t, 0 in for t, 2 pi in for t, and pi into t. And once you do that, the final answer is just 0. But then again, that's only when n is equal to 1. Now we have to look at when n is greater than or equal to 2. So our second use case is when n is greater than or equal to 2. Well, this is a bit tricky. So once again, we have our original solved integrand over here. So let's just copy that so we don't have to keep going up. Alright, so now that we have this equation, let's try and solve it when n is greater than or equal to 2. Now, how do we do this? Well, it's a little bit tricky, but let's walk through it together. Alright, so let's solve this integrand first. So we get 1/2 integration of negative n plus 1 cos 1 plus n t Now, since we have solved this integrand, let's start to put in the values. So 0, pi, and 2 pi are values of t, so let's replace them. Alright, so after solving this integrand, which started from over here, we got this whole thing, and yes, it's getting really confusing, but I promise you the answer is pretty simple. So now what we do, we have to see some sort of relationship. And how do we do that? Well, this is actually the most important part of this problem, so it's really important to listen carefully. So we see that we have this cos 1 plus n pi, cos 1 minus n pi, cos 1 plus n 2 pi, cos 1 minus n 2 pi, and we see some sort of relationship between them, since from all the way up here, we know that n is a natural number. If you go all the way down here, let's say that when n is an even number, so when n is even, then we have to find the value for all of these, because we know that cos of pi is -1, cos of 2 pi is 1, and if you add 2 pi to each one of those, it's going to give you the same answer. So when n is even for cos of 1 plus n, like over here, cos 1n pi, then this would be, let's see what it would be equal to. Well, if it's even, let's say it's 2. So then cos of 1 plus 2 pi, that's cos of 3 pi, and cos of 3 pi is -1. So that would be equal to -1. And this is true for all the even numbers. If you put 4 in, for example, you're still going to get -1. Now that we have that, we have to do it for all 3 of these. So then cos of 1 minus n pi, cos of 1 minus n pi. Let's see what that is equal to. So we have cos of 1 minus 2. I'm taking 2 because it's even, but you could take any number. Then you get cos of minus pi, which is also equal to -1. Then we have cos of 1 plus pi 2 pi, cos of 1 plus n 2 pi, 1 plus n 2 pi. We do the same thing, then we get 1, and then we do the same thing for cos 1 minus n 2 pi, 1 minus n 2 pi, and we get 1. And how I got all these values, you just replace the n for even number, I just did 2, and that's how I found these values out. But we're not done yet. This is only when n is even. But we also have to do it when n is odd. Because when n is odd, we're going to get a different value for each of them. So now we have to see when n is odd, then cos of 1 plus n pi, what would it be? Well, let's take 3, since 3 is an odd number. Cos of 1 plus 3 pi, cos of 4 pi. Well, cos of 4 pi is just 1, so we get 1. Now, cos of 1 minus n pi, 1 minus n pi. Let's replace 3 again. You get cos 1 minus 3 pi. That's cos minus 2 pi. Once again, that's still 1. Then we have cos of 1 plus n 2 pi. And that's going to be 1 if you replace the value of 3. And you have cos 1 minus n 2 pi. And that's also going to be 1 if you replace the value of 3 or any other odd number for that matter. So now we have when n is even and when n is odd. So now let's take this whole thing and start replacing it. So I'm just going to copy this whole thing so we don't have to keep scrolling back up. Alright, so now we have this, and let us solve it. So let's do this when n is odd. So what will we get then? Well, we have 1/2 minus 1 over n plus 1. Cos 1 plus n pi when it is odd is -1. So then essentially we multiply this by -1. If you multiply it by -1, then this -1 gets canceled. So that's just going to be positive 1 over n plus 1. Then we have a minus 1 over 1 minus n. What's cos 1 minus n pi when it is odd? Cos 1 minus n pi is -1. So once again, we can do that addition sign since negative times negative is positive. And then let's just quickly solve that. So then we get plus 1 over n plus 1 plus 1 over 1 minus n. And now you see it's kind of getting a bit more manageable. So then we get minus 1/2. Now we're solving this whole thing. So then we get minus 1 over 1 plus n. Cos 1 plus n 2 pi is 1. So times 1 is just going to stay the same. Minus 1 over 1 minus n. Cos 1 minus n 2 pi is also 1. So that's also going to stay the same. And let's quickly solve this. So you get minus 1 over 1 plus n minus 1 over 1 minus n. Now let's start solving this. We get 1/2. This is 2 over n plus 1 plus 2 over 1 minus n minus 1 over 2 minus 2, 1 plus n, which are these two, minus 2 over 1 minus n, which are these two. Further simplifying this, where'd it go? Okay, further simplifying this, we get 1/2 n plus 1, 1 minus n. We get 2 minus n plus 2n plus 2 minus 1/2. Let's take the minus out, in fact, so we get this. And then we are left with 1 plus n plus 2 over 1 minus n. Hey guys, sorry, I just realized I made a mistake. So originally it was plus, but actually it's supposed to be minus. But it's okay guys, we all make mistakes. So let's just go back down here. And once again, this is also supposed to be minus. And then let's solve this. So we know that all of this top row is right. So this has to be right. And then we know that this is right. We know that this is right, excuse me. And then we have plus, plus, because minus times minus is plus. Same with this. And now we have plus and plus right here. So then we can't take the minus out. And then we just simplify it once again. Let's just erase all of this. And then let's quickly just simplify it. Simplifying this, we get 2 over n plus 1, 1 minus n. Here we get we get 4n, 1 minus n, 1 plus n, 1 minus n. This stays the same since we've already simplified that. This is equal to 2. Oh, there is no n. These n's got canceled out. This is 2. 1 plus n, 1 minus n, which is equal to 0. So that is when n is odd. Let's do that when n is odd. We still have to do that when n is even, but it's the exact same procedure. We already know each of the individual values when n is even. So then we can use this equation. Let me just highlight this. We can use this equation and replace the values of n, replace these values, replace these values in here to find the answer. And once we do, and once you do, we are going to find that when n is even, then the answer will be 4n plus 1, negative 4, n plus 1, n minus 1. And then now, since we calculated the values when both n is odd and n is even, we can say that when n is an even number, so when n is even, this is equal to minus 4 n plus 1. And when n is n plus 1 and minus 1. And then when n is odd, we can say that this is just equal to 0. And that is our final answer. And yes, this whole question was really tricky. We made some mistakes along the way, but ultimately, as long as you know what you had to do with those n plus 1s, oh, let me try to find it, guys. Oh, it was here. Well, as long as you know what to do with the when n is odd or when n is even, then you're pretty much set to go. But overall, it was nothing new. If you knew how to calculate integrand with trigonometric functions, then hopefully it was nothing new. It was just you have to think a little bit outside the box to arrive at this answer when n is even and when n is odd. So yeah, I'll see you guys next time, and thank you for watching.